All right, so this is our 5-3 side angle side or SAS theorem day. So please make sure you're putting the date and the topic on the top right of your notes. Then you're going to set up your lines, okay, for your Cornell notes. And our essential question today is, what is the side angle side theorem? What is side angle side, and what is it used to prove? Our learning target, we're on 5C. I can prove two triangles congruent using the side angle side theorem. And if you want to start abbreviating side angle side as SAS, that would also be fine. All right, so what is the SAS theorem, side angle side? Basically, it says if you have two sides and the included angle, if you know that there are two sets of congruent sides and the included angle is congruent, if you get those three pieces of information, then you can conclude that the two triangles are congruent. So notice on the diagram we have one tick mark, we have side, angle, side. So it's very important that it goes in that order, side, angle, side. It can't be like side, side, angle. All right, so side, angle, side with the included angle. So instead of having to find all 6 pieces of information, all 3 angles and all 3 pairs of sides, you can use this shortcut. You can use 3 pieces of information. So that's why it's handy. All right, so we're going to be getting back into proofs, but people generally like them a little better in this chapter. So example problems number 1, write a proof. Given BC is congruent to DA, BC is parallel to AD, prove triangle ABC is congruent to triangle CDA. So please make sure you draw that diagram. Then I'm going to go ahead and set up my statements and reasons. So I always, well, let's think about this. I'm trying to prove that triangle ABC, so ABC is this yellow triangle, is congruent to triangle CDA. Okay. So I'm going to start with what was given to me. So I'm going to start with this. I'm going to start with the fact that BC is congruent to DA, and that is given. I'm also going to say that BC is parallel to AD, and that is also given. So we always start with what's given. Okay, so we have one pair of sides that are congruent. Now, I'm thinking, since it's this chapter, but I'm thinking I want to use side, angle, side. Is there anything else? Well, these two triangles, if I split them apart, they both share side AC. So this middle side, AC, is congruent to AC. Does anyone remember from last section the reason why? If they share a side, that is your reflexive property. Then lastly, I need to talk about the included angles. So these angles right here. Since I have parallel lines cut by a transversal, I can say that those two angles are congruent. So I can say that angle BCA, I do need to use 3 letters, is congruent to DAC. And those are alternate interior angles. So I have side, angle, side. All right, so the last thing is triangle ABC is congruent to triangle CDA. And that is the side, angle, side theorem. So you're going to be following kind of that template for your proofs, listing a pair of sides, the included angle, the other side, and then that the two triangles are congruent. And we'll get more practice. All right, in the diagram, QS and RP pass through the center M of the circle. What can you conclude about triangle MRS and triangle MPQ? So let's start by kind of marking up the diagram and thinking about what we know. So basically we know that RM, this is a radius from the center to the outside. SM is also a radius. MP is a radius. MQ is a radius. So we have 4 congruent sides, okay? And then if you think back to chapter 1, we have kind of an X picture. So we have vertical angles. So we have the included angle. So we have side, angle, side. So we can use the side, angle, side theorem to prove these 2 triangles are congruent. All right, so we always start with what's given. Okay, M is the center of the circle. Okay. We know that RM, I'm going to start with the top triangle, RM, okay, is congruent to QM. And how do I know that? That's basically the definition of a radius. They're both radiuses, or radii, so they're congruent. All right. So I did my sides. I'm going to put a little check right here. Then I'm going to do my angles, So I'm going to say angle SMR. And if you had said RMS, that would also be fine. But I'm starting with this top triangle, this yellow triangle. So everything on the left should be from that triangle. All right, is congruent to angle QMP. And my reason is those are vertical angles. And then I need to do my last pair of sides. So I did an angle, then I'm going to do a side. So now I'm going to do side SM right here. Side SM is congruent to PM. And again, those are both radiuses. So I'm going to say definition of radius. So I started with what was given. I did my side, my included angle, my side, angle, side. Now I'm ready to conclude that triangle MRS is congruent to triangle MPQ using the side, angle, side theorem. All right, so pause if you need any more time. We're going to try one more. All right, last example. So you can kind of summarize what you need. You are making a canvas sign to hang on the triangular portion of the barn wall showing the picture. You think you can use 2 identical triangular sheets of canvas. So I would say you need this part, kind of the math part. You know, and I'm going to maybe draw this triangle below because it's really hard to see, I think. So P is right here, S is right here, R, Q, right angle, and on the diagram, this is marked. It's hard to see, but it's marked on your diagram. Okay. Okay, so we're trying to prove that the 2 triangles are congruent. We're trying to prove triangle PQR, this yellow part, is congruent to triangle PSR because we want to use the same identical sheet of canvas for our sign. So let's start with what is given. Okay, it's given that PQ is congruent to PS. Okay, that was given to us on the picture, given to us in the problem. Okay, it's also given that RP is perpendicular to QS. That is also given. Okay, So that's what's making the right angle. So if this is a right angle, I also know that this is a right angle. So I'm going to go ahead and say, I'm starting with the yellow triangle, QPR, PQR. I need to start with angle QPR. Is congruent to SPR, angle SPR. And you could say that they're a linear pair, supplementary. I'm going to say the definition of perpendicular lines. There's a few things I would probably accept for that reason. So I've done a side right here, a side. I talked about that they were perpendicular. I've done an angle. Now I need to do another side. So hopefully you're starting to recognize that PR is congruent, or PR is congruent to PR. If you said RP and is congruent to RP, that would also be fine. And that is, again, the reflexive property. They share that side. Okay, so lastly, since I have side, angle, side, I can say that triangle PQR is congruent to triangle PSR. And that is using the side, angle, side theorem. Okay, so hopefully you're kind of noticing it kind of has a structure, a format. We start with what's given. We list a pair of sides and the reason. We list the included angle. We list another side. And the last line is that the two triangles are congruent using side, angle, side theorem. All right, for homework, that's on big ideas. Summary, what is the side, angle, side theorem? What does it allow you to do? So remember last section, our proofs were really long because we had to list all three pairs of sides and all three pairs of angles. So the side, angle, side theorem is a shortcut,